Good morning. Is it started yet? Sorry.
Yes.
Okay. Good morning. My name is Dennis Falloon, and I am a District 7 consultant and the Safety Academy coordinator for District 7. And I'd like to welcome you to the 11th topic of 12 for this current year of 2014. And today's topic will be addressing traffic safety and operational impacts of new developments. It's a little different than what was sent out in your notice, but it was changed early on. We just didn't get that change made. It's going to be presented by Jim Scott, PE, who's based in the District Maintenance Office in Tampa, District 7 office. And he is the District Permits Engineer and District Access Management Engineer for District 7. I'm going to go in and give you a little intro to the Academy. As I stated before, this is District 7 Local Agency Traffic Safety Academy, and the purpose of it is to provide the local agencies safety-related information to enhance your local safety programs. This set of topics began in March of 2014, and the period of time we set aside is like 10 a.m. to 12 p.m. And they usually run for about an hour. The complex ones might run longer than that, but no more than 2 hours. And as Anthony had mentioned earlier in his intro, you can register through the website that he showed you, which is also listed here, and also the website link that he had up there. And just to reinforce what he said, the recordings and the PDFs of the presentations are listed on that website. As I mentioned earlier, today is addressing traffic safety and operational impacts of new developments. And if you are an engineer, professional engineer, and you want to get PhD credit, you can follow this process going to LarryHaganConsultantServices.com, or you can fax a form to him, and that form is also out on the website that Anthony showed to you previously. And here's also that link again. Also, these topics have been submitted for the AICP credit, and you'd have to go out there and see what's been approved and placed out there if that fits you. Also want to mention the third series of traffic topics are currently under development, and as of this week we selected the 12 topics. We have not put them in the order we want or finalized the presenters, so that will be coming hopefully next month, so you can start registering, because we plan to begin in January, probably toward the end. And my contact information if you have any questions or anything. And with that, I'd like to turn it over to Jim to give his presentation.
All right, let's make Jim the presenter here. And again, if anybody has any questions during the presentation, go ahead and type them into the chat, and we will do our best to answer the questions while that slide is still up.
Well, good morning, everyone. My name is Jim Scott. Glad to be with you this morning. We were earlier talking about the weather, and sure enough, in Tampa, it's in the low 40s today, which is a little chilly, so it's good to be inside rather than outside. Dennis had mentioned the title. Well, sure enough, I didn't tell anybody, but I've changed the title for the third or the fourth time. Currently, the title is Role of the Permitting Process in Enhancing Traffic Safety. I left off and operations in enhancing traffic safety and operations. I guess most of us realize that usually whenever we make a decision that improves traffic safety, it usually improves the traffic efficiency or the traffic operations. That's not always the case, but usually the case. So whenever we mention today in this presentation traffic safety, you can pretty well plug in and traffic operations also. I wanted to stick with the title and discuss two more points in the title today. First of all, as Dennis mentioned, I'm the District permits engineer. That's in the maintenance office. And so we deal with a variety of permits, utility permits, drainage permits, what we call construction agreements, road closure permits, the banner permits. They go on and on. And then also we're responsible for the connection or the driveway permits. So the permitting process that I'll be speaking to today is really the driveway permitting process that the DOT uses. And that process pretty much follows the Florida Administrative Code 1496. That's the rule chapter that deals with connection permits or driveway permits. So what we'll be talking about primarily is permitting that hopefully safely gets folks in and out of a development. It's not the detailed permitting process that local governments require for some of their processes, for instance, for large developments like DRIs or for concurrency. It's primarily concerned today, we're primarily concerned today then with the access, safe and efficient access to and from the property. And the second point I wanted to make really about the title, enhancing traffic safety. Well, can we enhance traffic safety? Can we improve traffic safety? You know, every now and then through the permitting process we can. We might have a situation where there's a left turn lane that's been there some time, and over the years more and more traffic, left turn traffic, has been using that left turn lane, and sure enough maybe the left turn lane queues back into the through lane in the morning. And then we could have the possibility of rear-end crashes, and so we want to make sure we lengthen that left turn lane. Well, before we're able to lengthen the left turn lane, you know, possibly if we get lucky, a development might come in that would impact that same turn lane, and they'll widen the turn or lengthen the turn lane for us. And sure enough, in that case, we're probably enhancing the traffic safety by lengthening that left turn lane. But most of the time, whenever a new development opens their doors, you know, they're going to generate more traffic, and that'll mean there'll be more through traffic, and there'll be more turning traffic getting in and out of the development. And as we probably know, you know, the more traffic we have, and the more conflicts we're going to have. The more conflicts, you know, some folks unfortunately are going to make mistakes, and when that happens, those mistakes could likely turn into crashes. So it's going to be difficult to improve on traffic safety during the permitting process, so we probably can't do that. But certainly we should be able to mitigate the impacts of new developments on traffic safety. And the way we do that is addressing the access management features that go into a development's access. The driveways, for instance, determining the right number of driveways, the proper location of the driveways, the proper design of the driveways, turn lanes, whether or not turn lanes are warranted. If so, how long do those turn lanes need to be? We need to address median openings. It might be that we need to adjust a median opening, change it from a full median opening to a directional, or possibly close a median opening. We may need to close a median opening so that we can lengthen that left turn lane. Maybe it's just adjusting a median opening or relocating it a little further away or towards the development. You know, in Florida, whenever we affect median openings, then we certainly want to make sure that the businesses and the property owners are aware of the median opening change. So we contact the property owners, and actually in our district we put up a little sign at the median opening so that folks know there's going to be a change there, and they have the opportunity to call and talk to us about that change. And then if the development's large enough, it generates enough traffic, maybe there's the possibility that a traffic signal is the proper design feature that needs to be added to the roadway. So how do we go about mitigating the impacts? Well, we have to have a plan, and the plan we use typically is the traffic impact study. So one of the major topics today that we'll talk about is traffic impact studies. And then after the traffic impact studies, I just wanted to go over how you can find some of the DOT references that we're going to be talking about today. that won't take too long, but I will go through these references so you can find them easily. And then the last little section, I call it Stung by the Standards. I'm not sure if that's the proper title or not, but it's really just some observations I've made over the years and some thoughts I have about some of the access management features, and I'll spend a little bit of time talking about those. This last little topic, it's really for your consideration. Again, it's really thoughts that that I have. So the first topic is the traffic impact study, and if you work for the DOT, as far as I know, we only have 2 documents that really speak to traffic impact studies. The first, I've already mentioned a little bit, is Rule Chapter 1496. If you're not familiar with the Florida Administrative Code, it has a number of divisions within the code, and division number 14 are the DOT, the Department of Transportation numbers. So anytime you see an FAC 14, that's going to be a DOT rule chapter. I'm not really sure how many there are now. I know there's over 100. There's 2 of them that speak to permitting and access management. We'll talk somewhat now about the 1496. I won't mention a whole lot about 1497. 1497 is the access management classification and the standards, the spacing standards for the access management features. So, for instance, 1497 is where you'd go to find the spacing standards based on the roadway classification and the speed limit for driveways and median openings and traffic signals. So the first document that we're going to talk about, DOT document, is 1496. It doesn't have a whole lot of detail. You can find out a lot more detail in the Transportation Site Impact Handbook. This is a planning document, and it has a chapter on impact studies, and it goes into quite a bit of detail up to the point, really, of making the decisions. In other words, it has a lot of information about collecting the data and the estimating the trips and determining what the traffic volumes are going to be at critical locations. But from that point on, it doesn't give you a whole lot of guidance then on what to do with the information. Not a whole lot of guidance on how to analyze the information or what recommendations or mitigation steps you might take based on the information that you have. So the third area I want to talk about under the impact study is just some of the analysis that I typically use. They're kind of the quick and dirty little formulas that I use for turn lanes and things of that nature. So let's talk about Rule Chapter 1496. Again, that's the driveway permits rule chapter. And it has some good information, not a whole lot, but it does have some good information. It tells us when impact studies are required. It gives us some guidance on traffic data. Again, not a whole lot of guidance, though, when it gets down to the nitty-gritty, when we need to determine the analysis and also what mitigation is necessary. So when do developments require studies, or when do we require the development to provide us a traffic impact study? Now, in our rule chapter, the various driveway permits are classified according to the number of trips they generate. And so, for instance, a Class D category permit has 1,200 trips. In fact, I believe it runs from 1,200 trips to 4,000 trips. That's a Class D, and there's also higher classes up to a G. And the rule chapter tells us that whenever we do have a Class D category permit with 1,200 trips per day, then we should require the traffic impact study. I know there was a lot of times when I felt like there was really just nothing to be gained from the study, that we weren't going to be able to find any improvements that would benefit the public, that we didn't require the study. but that's kind of come back and bit us from time to time. People will ask questions about why didn't we lengthen the turn lane, or why didn't we add right turn lanes, and it's kind of hard to remember all that. So the study's required, so we require the applicant through their engineer to provide a signed and sealed traffic study. What the study also does, it also forces, in this case, let's say me, it forces me to spend more time on each of these developments. I'm reading through the study and analyzing the information in the study. And every now and then, you know, we can come up with some, usually little, or some improvement that will help mitigate the impacts of these new developments. So we're going to require the impact study every time the daily trips exceeds this 1,200 trips per day. The rule chapter also mentions the Class C permits, which are permits where the daily trips are between 601 and 1,200 trips a day. And you can require studies for the Class C permits, but we usually don't. We really haven't found them to be beneficial at all. But it is the DOT's call if you think there's some benefit that you can gain from those particular studies. And the rule chapter also talks about signing and sealing the studies. The studies have to be signed and sealed by a professional engineer. You know, after all, they are a traffic engineering study. And since they're signed and sealed by an engineer, then the rule chapter also states that they're supposed to be reviewed by a PE. If they're not reviewed by a PE, then the study should be reviewed by someone under the supervision of a PE. Pretty much common knowledge, but that is specifically mentioned in the rule chapter 1496. There's a little bit of information on trip generation. When we submit, or when the applicant submits the application, the driveway application or connection permit application, he has to show the estimated number of trips on that application. And he has to show us which land use code from the trip generation manual that he used. So, you know, that's good information to know. And again, the information on trip generation does mention the ITE trip generation manual. I'll talk about that a little bit later on. And it also tells us that when tells the applicant when they're estimating the peak hour trips, or when they're estimating the traffic, they should estimate the peak hour trips too. Usually the peak hours are going to be in the morning peak hour and the afternoon peak hour. They should provide those estimates not only for the peak roadway times, usually the morning and the afternoon, but also the peak times of the development. Sometimes they're the same, sometimes they're not the same. So it's good to identify up front what information that, in this case, the DOT will require from the developer, and well, we'll kind of mention that a little bit later on too. And then really the last bit of information that's required from the traffic impact study, according to the rule chapter 1496, is the applicant is required to determine the peak hour turning movements, and that would be for all the critical locations or intersections. So that would be the driveways and the median openings and the adjacent streets. But this information really isn't very detailed, and it really just never tells you how to even collect this peak hour turning movement information. You know, there's really no discussion or no mention of the background traffic or the existing traffic at these locations. No mention of the trip distribution or trip assignments. So in that regard, it's, you know, it's certainly lacking from information, and it would be very difficult for you to complete a traffic impact study with the guidance that's in Rule Chapter 1496. As far as analysis and mitigation, I'll just read this, but the only time it's mentioned is it states that the study must include a traffic operations analysis of sufficient depth to analyze the impacts of the development on the surrounding transportation system. Well, that sounds good, but what does that mean, and how do you go about analyzing that information? So we really need more guidance. Fortunately, we do get a lot more guidance, at least on the determination of the traffic volumes, in the planning document, the Transportation Site Impact Handbook. And this handbook, it covers a lot more than just the permitting that we're talking about today, but it does have a good chapter on traffic impact studies. Again, it's a good chapter with a lot of detail on the data collection and the data estimating for the traffic volumes. But when it gets to the analysis, then it really doesn't offer a whole lot when it comes to the analysis and the mitigation. But I would like to go through the steps then that are in the Site Impact Handbook. And the very first step, and of course this is always a crucial step, and this step is actually mentioned in the Rule Chapter 2. I just didn't mention it. We call it the pre-application meeting in the Rule Chapter. The methodology meeting is the term that I think you would probably hear, frankly, more frequently. But this is the meeting where, in our case, the DOT would sit down with the developer, with the applicant, and discuss the project and try to set the ground rules for the project. So, for instance, if the DOT has any preferences, if we're concerned about the land use code they want to use, we'll talk those over. We'll determine when the peak hours should be. As we know, really, the traffic impact study, ultimately what you want to do is determine what's going to be the effect on the roadway during the peak hours. So during this methodology meeting, we'll determine what peak hours and make sure we agree on the peak hours that need to be studied. And it might be that we absolutely wouldn't entertain a traffic signal. Maybe there's a traffic signal already existing 500 feet away from where they're possibly proposing a signal. Up front, we'll tell them that they can't consider a traffic signal. They need to come up with other access management features to try to mitigate the impacts that they thought they could correct maybe with the traffic signal. And then we encourage the developer to bring in at least his initial site plan. We want to review that and take a look at it and certainly make comments on it. It might be that they're asking for too many driveways. Typically, we start with one driveway, and really, for most developments, one driveway is probably going to be all that we would approve. The location of that driveway is important. We'd want to talk about that. The site circulation, that gets to be very important, especially when you have properties that just aren't perfect. They're narrow, or maybe they're a little smaller than they need to be for the development. So the site circulation is important. How they're going to get their delivery vehicles in and out, that's certainly something we want to know about also. If we're aware, and we really need to check this through our work program before the meeting, but if we're aware of any future DOT projects, we should let the developer know about that. Any future developments that are coming into the area that we know about, we'll usually tell them about those too. Most of the time, the developer is going to know more about the proposed developments in the area than we will. But still, if we know something, we want to certainly mention that. And then just go over the permitting process with the applicant. Make sure he understands who the contact point will be with the DOT and how our process works and what offices would typically review his traffic impact study, about how long it should take, and then any other questions he might ask, so that when we leave the meeting, when the applicant leaves the meeting, hopefully everybody understands the ground rules, and we can move forward quickly with the permitting process and what we're talking about today, especially in the review of the traffic impact study. And then the second step in the Site Impact Handbook is the section on trip generation. And this is a pretty detailed section. It had, frankly, a lot of good information in it. It happens to be in Chapter 2.4 of the Site Impact Handbook. And it tells us in there that typically the peak periods in the morning and the afternoon are when we need to estimate the traffic for the development. That's true probably 95% of the time, but sometimes the peak traffic might be on a weekend. It might be, for some of these big box stores, early Saturday, early Sunday afternoon, or right around lunchtime for that matter. And then there is also a lot of information about the ITE trip generation manual. Again, it recommends using the manual. And it does mention some of the pitfalls of using the manual and helps with guiding you through using the manual to some degree. But really, as far as using the trip generation manual, you really should go just straight to the source. Hopefully you're familiar with the spiral little notebook, the little over ½ an inch notebook. It's called the user guide for the manual. And that user guide, I think it's the user guide and handbook really, but that user guide and handbook, that's where you need to read up on how to estimate traffic. Otherwise, you're not going to know whether you should be using the weighted average rates, the regression equation, or if neither apply for this particular land use code under these conditions, and you need to use the local data. You really won't know how to use the manual if you don't use the user guide of the manual. So I'd recommend that before you start using the trip generation manual, make sure you're familiar with the information that's in the user guide. So after you have your trips estimated, the next step is the trip distribution. And that's where we determine, or in this case the engineer working for the developer, he determines where the trips are coming from that are going to the development, and the trips that leave the development, where those trips are going to. And the trips coming in, of course, should equal 100% because you ultimately want to use the percentage of those trips on your trip distribution diagram. So the percentage of the trips coming in should be 100% to the trips coming in at the site, and then the same with the other way. That should equal 100% also. What most folks use that I'm familiar with is for the new project trips, they use the regional planning model for the area. And if it happens to be a development that has passerby trips, in other words, if it's a convenience store or service station, if it's a fast food restaurant, and they rely heavily on pass-by trips, then you just need to use the existing background traffic and use that background traffic to determine where the trips are coming from and where they're going to. So when you get through with the trip distribution, you should have something similar to the drawing you see on the right-hand side that shows the percentage of the trips and where the trips are coming from and where they're going to. Now, after you have the trip distribution and you know the estimate, or you have an estimate of the number of trips generated by the site, use that information to come up with your trip assignment. And this is the project traffic. So you determine what the project traffic is going to be for each of the turning movements at each of the critical locations. So you determine the turning movements then for the driveways or driveway, individual driveway, the median openings that might be affected, and also the intersecting streets. And once this effort is completed, this step is completed, then you should have a drawing that pretty much shows all the turning movement counts and the impact that the traffic only generated from the site will have on these intersections. Now, in addition to the estimated traffic, certainly you need the background traffic or the existing traffic. So you need to make turning movement counts at each of these critical locations. Again, it's the same three really: the driveways, if there's already existing driveways; if not, the intersecting streets and the median openings. And you need to make these turning movement counts, manual turning movement counts, of course, during the peak hours. That's the time frames that we've decided we're going to study. Other information you'll need in order to be able to complete your analysis, you need to collect the existing roadway conditions. So you need to know the number of lanes along the roadway, if there's left turn lanes, right turn lanes, how long the right turn lanes might be, how long the left turn lanes might be, where the median openings are located, the distance from adjacent driveways to the proposed driveway or driveways, and the location of the adjacent signals in the area. And that's really the last step in the Site Impact Handbook that frankly is of any real value. There's two other steps. One of them is called the Access Management, Site Access, and Internal Circulation step. Basically, it tells you that you need to assess the safety and operational impacts of the development, but again, doesn't really tell you how to do that. Just tells you it needs to be done. And then the last step in the traffic impact or in the Site Impact Handbook is the step on mitigation. And there again, it pretty much tells you that if you got a problem, you need to mitigate that problem. But it really doesn't tell you how to do that. So I guess reviewing the Transportation Site Impact Handbook, again, and I won't repeat this more than one more time, very little guidance on analysis and mitigation. And in fact, it missed another step, or at least I never could find this step. It's an obvious step, but I never really could find the step where you would want to combine your background traffic with your site traffic so you'd have your total future traffic at each of the critical intersections. That's pretty much understood, but I really couldn't find it anywhere in any of the steps in the Site Impact Handbook, so you just maybe need to be aware of that. So now we've collected the data and we've got all the traffic volumes we could possibly use. We just need to do something with them. So what I wanted to talk about next then is analyzing these access management features. The very first feature, would be the driveways, and I'm going to defer on that. The department has the driveway informational guide. Hopefully you're familiar with that. But it's a very good document. I think the latest version is about 6 years old, but it's a very good document on how to design driveways, and it goes into a lot of theory and concepts, so it's not just throwing out design standards at you. It's got a pretty good explanation of why you're supposed to do what's in the information guide. So I'm not going to really talk about driveways, but do want to talk about turn lanes in detail, or at least as much detail as I know. And then also want to just mention median openings. As we know, there's no real warrants for median openings, but just mention median openings, and of course there is warrants for traffic signals, but just mention traffic signals. Ultimately, the traffic signal decisions, frankly, are going to be made by the Traffic Operations Office. So let's talk about the right turn lanes then. Should a right turn lane be considered? Well, in reviewing the traffic impact study, what I do is I go and use information that's out of the driveway information guide. Again, the current version of that guide is about 6 years old, 2008. But in that guide, there's a chapter called "When Should We Build Right Turn Lanes?" And it's based on NCHRP 420. And in that chapter, it discusses a range of right turn volumes where you need to start considering adding right turn lanes. And what I did quite a few years back really is I tried to decipher the range based on speed limits, based on the type of roadway, type of facility. And I came up with my own little table that I've always used. So this little table that you see, that's strictly mine, so be careful with it. But I'm going to claim it's based on the driveway informational guide, and the driveway informational guide, I believe, is based on NCHRP 420. So for instance, using this table, if you have maybe 60 vehicles an hour that are making right turns on a 6-lane facility, and the speed limit happens to be over 45 miles per hour, let's say the speed limit's 50 miles per hour, then the warrant is 55 vehicles per hour. So the 60 is higher than the 45, higher than the 55 vehicles per hour. So in this case, we would want to consider adding a right turn lane. Just because we want to add the right turn lane there's still a number of other considerations that we need to think about. First of all, do we have the right-of-way to add the right turn lane, to construct the right turn lane? And if we don't have the right-of-way, is there enough frontage for the development to construct a right turn lane? Sometimes there is, sometimes there's just not. Most of the time, I'll claim the right turn lanes aren't that expensive, but I do know of situations where in order to construct the right turn lane, it would be too expensive, where we've had double box culverts that would have to be extended, or there might be utilities that would be just too expensive to relocate. And so for that reason, sometimes even though the right turn lane was warranted, we didn't feel we could require the right turn lanes. And then we've had situations, maybe we'll say in downtown areas, where there's really just no right turn lanes present anywhere. And so even though the right turn volume might meet the warrant, we decide not to add right turn lanes. So after you've made the decision to require the right turn lanes, what are we looking for in the way of the length of the right turn lane? We're probably familiar with the turn lanes and the makeup of turn lanes, the queue length, the decel length, and the taper length, and you add all three together to determine what your turn lane length is going to be, and that would apply to right turn lanes and left turn lanes. For signalized intersections where we want to add a right turn lane, typically the engineer is going to also study the signalized intersection using traffic modeling software. Seems to be the software of choice right now is Synchro. And so you can use a Synchro model and use the queue length straight from Synchro for signalized intersections, and that's usually what I do. I'll take a look at it, see if it seems to be appropriate, but that's probably about it. For non-stop conditions, in other words, if you don't have a signalized intersection, and I guess the typical condition you would have at driveways, we assume that the queue length is going to be 0, that really nobody's going to have to stop. They're going to be able to keep moving. So the queue length there would be 0. And so now that we know the queue length, we need to add the decel and taper to that queue length, and that's pulled straight from Standard Index 301. I know you can't read the standard index here. You might be able to load it up and read it, but for instance, a lot of our roadways have a speed limit of 45 miles per hour, and for a 45 mile per hour speed limit, the decel and taper distance is 185 feet. So you'd add that 185 feet to the queue length, and that would give you your right turn lane length. Now, left turn lanes, should a left turn lane be considered? Well, if it's a signalized intersection, we need to try to add the left turn lane length, left turn lanes. We need to separate the left turns from the throughs and the rights. So we're going to always consider or say yes to a signalized intersection. For a non-signalized intersection, what I've used over the last few years, and maybe it's been quite a few years really, is this NCHRP 557. It's the engineering guide for evaluating intersection improvements. It has a interactive spreadsheet, and spreadsheet is pretty handy, convenient, fairly easy to use, so that's probably telling you why I use it. But anyway, that's typically what I use to determine whether or not we need left turn lanes. This spreadsheet, the NCHRP 457, it's based on the Harmlich study that was done 40 or 50 years ago. It's been around forever, but I don't know if there's anything better. Maybe there is. Maybe somebody can point me in the right direction. But anyway, it's based on the Harmlich study, and the Harmlich study is based on the probability of a through vehicle running into or arriving behind a stopped vehicle that's wanting to make a left turn. So if that's the reason for installing the turn lane, then the information that you need in order to determine whether the left turn lane is needed or not, first of all, you need to know what type of road it is, a 2-lane road, or actually for NCHRP 457, it only has the 2-lane road and the 4-lane road. If it's a multi-lane road, I go ahead and use the 4-lane spreadsheet. I wish I'd have used something besides what I ended up showing here. I showed the 2-lane roadway and I showed the metric version. Certainly there's English versions too, but it really won't make any difference in this example. So you need to use the proper spreadsheet based on the number of lanes, and then you need to know the traffic during the peak hour. You need to know the advancing volume. That's the traffic that's traveling in the same direction as the motorists that want to make the left turn. And then you need to know the number of left turners during that peak hour. Actually, you don't use that number. You go ahead and divide the advancing volume by the number of left turns to come up with a percentage of the advancing volume that's making those left turns, and you use that percentage. And then you need to know how many motorists are opposing the left turners. So with that information, you just plug that information into the spreadsheet and push enter, and it'll identify a little red triangle. And if the red triangle is on the right side of the curve, then that's going to mean that you should try to add a left turn lane. If it's on the left side of the curve, then you're okay. The volumes just aren't high enough where you need to be concerned about left turns. Obviously, anytime you have a left turn vehicle and it has to stop on a 2-lane road, let's say, you've got the probability, or there's the possibility that you could have a problem, but we can't require everybody to put in a turn lane under every circumstance. So that's the method that I typically use for the left turn lanes, determining whether or not we need a left turn lane. Now the queue length of the left turn lanes. Well, I've already mentioned the synchro run, and certainly you can use a synchro analysis and use that queue length that it's identified for the left turns. Or in our plans preparation manual, they use a formula, and it's kind of a quick and dirty way you can estimate what your left turn lane queue might be. And basically what you're doing here is you're just taking the number of left turns during the peak hour, and you're dividing it by the number of cycles, traffic signal cycles in that hour. So what you end up with then is the number of left turns that are arriving each cycle, and then you, in order to be on the safe side, you're doubling that number, and you say then that the queue length for storage for queue needs to be the number of feet of a typical vehicle, 25 feet, times the number of vehicles. In this case, it would be 2 times whatever the, well, in this case, we won't do the math right here. I was going to do it actually on the next slide. But you multiply the number of vehicles times 2, and then multiply that by the 25 feet to get your queue length. I suffered through that. I should have just gone straight to this this example. Yeah, here in this example, the assumption is that it's called the DHV, but really it's the design hour vehicles, but we're talking about left turn vehicles. So in this case, we're going to assume there's 100 left turn vehicles during the peak hour, and assume that the cycle length is 180 seconds per cycle. If you divide the 180 by the number of seconds in an hour, 3,600 seconds, then you'll come up with 20 cycles. So 20 cycles is your end value. You divide the 20 by the 100, so that means there would be 5 vehicles arriving every cycle. And then to be on the safe side again, go ahead and double that. So that's 10 vehicles. 10 vehicles times the 25 feet per vehicle is 250 feet. So in this example, the queue length would be estimated at 250 feet. It would be estimated at 250 feet. And that's for a signalized intersection. Now for a non-signalized intersection, the Florida Intersection Design Guide has a formula, again, that's easy to use. And from what I know, most people seem to use this formula. And this formula is based really on the number of left turn vehicles that arrive in the left turn lane within a 2-minute period. So the formula then is that design hourly vehicle divided by 30, which is the number of 2-minute periods there are in an hour. And then that'll give you the number of left turn vehicles per the 2 hours, multiply that by the 25 feet per vehicle, and then that gives you your queue storage. Again, an example of that might be that, let's say we've got 90 vehicles that are making a left turn at a median opening. That would mean in a 2-minute period, 30 divided by 90 is 3. There'd be 3 vehicles making that turn. So you multiply the 3 vehicles by the 25 feet, and so you use a queue length of 75 feet. Now, I didn't go into the decel and the taper on the left turn storage lengths. Obviously, we'd go back to standard index 301 and go through the same process we did for the right turn lanes to come up with the total left turn lane length. So that pretty well covers, I guess, our analysis of right turns and left turn lanes. Just like to make a few comments about median openings. There's no real warrants for median openings. Certainly we have our design spacing standards, and we want to try to follow those standards wherever we can. But ultimately, our decision really needs to be based not necessarily on the numbers, but ultimately on sound engineering judgment, I said. Experience, whether or not motors will be safer, and whether or not it'll be more operationally efficient to have a median opening or to not have a median opening, or to relocate the median opening or not relocate the median opening. For me, if there's no full median opening and somebody's asking for a full median opening, I try to stay away from new full median openings. If there happens to be a situation where we know we're going to have to signalize the new median opening, well, certainly you're going to need to put in a full median opening, but I generally want to stay away from full median openings that don't exist today. And the option a lot of times to me is the directional median opening. We'll talk about that a little bit later. In fact, I think it's about the last thing I talk about today. But I used to say that the directional median openings, they're a good compromise. The developer wants the full median opening. Maybe the DOT staff wants the no median opening and doesn't meet our standards. So maybe a good compromise is a directional median opening. But frankly, it's really more than that. To me, a lot of times it's the best option. So we'll just leave that right there for now and move on with the traffic signals. Don't want to say too much about traffic signals. Like I've already mentioned, ultimately the decision needs to be left up to the traffic signal experts, and that's the Traffic Operations Office. But
Jim, if I may, there's a question or there's a comment in the chat.
Okay.
The median handbook is another source, and it also has a simple lookup that I guess it's just a chart without needing to punch things into a calculator or needing a spreadsheet. So just so the audience knows, that's another place that they can look. There's a chart.
Yeah, that's good information. I don't remember the chart. I think the median handbook also mentions that if there is no guidance on the queue length, then for an urban area, a lot of times the queue length should be at least 2 vehicles for 2 vehicles, 50 feet. If it's in an urban area, the queue length should be long enough for 4 vehicles or 100 feet. I remember that. But anyway, yeah, that's certainly a good point. And the median opening handbook has a lot of good information. In fact, I believe it was recently, I think we finally updated it. So the new version now happens to be a 2014 version. I'll quickly mention it when we talk about references. Yeah, thanks for that
Great.
comment. Back to the traffic signals. If the developer wants a traffic signal, feels like they need a traffic signal, feels like it's best for the public traveling up and down that roadway, then they can submit the traffic signal study. In the state of Florida, the study should adhere to the MUTS manual, the FDOT MUTS manual, Florida DOT MUTS manual on uniform traffic studies. basically it says the same thing as the Manual on Uniform Traffic Control Devices, the MUTCD. So sometimes we use one manual, sometimes we say the other manual. We're really talking about the same basic study. 2 points to maybe keep in mind that really when the study is performed, even though the development might meet the numbers or the intersection might meet the numbers for one of the 8 warrants, really that's just the first step. Ultimately the decision really needs to be, will the traffic signal make the intersection safer and operate more efficiently? Will it benefit the public? And even though you meet the numbers in one of the 8 warrants, if there's really not a safety benefit, if there's not an operational benefit, probably shouldn't put in the traffic signal. But again, that's somebody else's decision. We'll leave that up to the traffic operations office. So I want to get into the references, and it just so happens, I guess, this is the page where we'll also see that median handbook listed. If you're like me, I don't want to use this term too often, but sometimes get a little lazy, and the quickest way to find a lot of these references, frankly, is just to Google it. Even if you're in the FDOT website, a lot of times it's hard finding things, and so I'll get out of the website or go directly to Google and find it quicker than just wandering around through the website. But you need to be careful about that, because you can have situations where you'll Google something, pull up a reference, and sure enough, it's not the latest version. So be careful if you're Googling references. The safe thing to do is to go to the DOT website, and planning has most of our access management documents. The systems planning office has quite a few of them. So the website that I've shown down here at the bottom in white, that'll get you to this particular page, which is the access management page, which is in the planning office page that identifies the documents. And here you can find the 2 rule chapters that we talked about, and the new median handbook, as well as the driveway information guide. And then also a planning document on the planning website. This is in the systems planning section. You can find the transportation site impact handbook. And of course we've already talked about it. It has a lot of good information and detailed information on getting to the point where you're ready to do the analysis, but then shies away some from the analysis. And then the last website I wanted to mention, you might have a little trouble trying to copy and paste the white web address that I've got here. But anyway, this web address then takes you to the documents page of the Office of Design. And the Office of Design has a lot of good publications. The ones I listed really are just 3. The design standards, which have that index 515, which I don't think we've mentioned just yet, which is the index on turnouts, what I call driveways, and then also the index 301 that helps us determine the decel and the taper for turn lanes. And then also, this is the location where you can find the Florida Intersection Design Guide and also the plans preparation manual, which we've mentioned from time to time. Now, the last topic that I wanted to discuss, again, I like this title because it was catchy, but I'm not really sure it applies, so bear with me on this. But just over the course of the years, I know that I've noticed some things, and actually some of the things I've noticed recently, and had some thoughts about some of the access management features and some of the things we do. So I just wanted to kind of bring these out. I wrote down here, standards work 99% of the time. I don't know how often we should follow our standards. Certainly we should most of the time, and should always, unless there's a really good reason why you shouldn't. To me, I'd worked in traffic operations for quite a while, and I've kind of hinted around these 2 questions already a couple of times, but whenever I had a traffic engineering question, or a decision to make, I'd always ask myself these same 2 questions, really. And the first question would be, will this decision enhance traffic safety? And will this decision enhance the traffic operations or traffic efficiency? And if the answer to both those questions was yes, then I always tried to do whatever the decision was. If the answer was no, then you should avoid the decision. It doesn't happen frequently, but sometimes the answer is yes to safety and no to efficiency. And then I guess then you got to go back to the drawing board and think it through a little bit closer. But I guess really what we're saying here is just step back sometimes from the standards. Ultimately, you need to make the best decision you can make, the safest, most efficient decision, or not decision, but operation is certainly what we're looking for. So I think I've cautioned you enough about about what I want to talk about. So let's go ahead and just get into some of these features. First of all, I call this narrow driveways, and I really haven't noticed this that much with permitted sites, but over the last few years, where I've noticed this has really been with design projects where we have a lot of consultants doing our work for us, and of course they do a great job, and we couldn't do the work without the consultants. But in some areas maybe they're not as familiar with certain features as maybe we might be, and so we've had some opportunities on some projects to modify driveways and actually reduce the number of driveways on certain projects. And when it comes to the driveway design, certainly everybody's going to use the 515, and for commercial driveways and index 515, it calls for a width between 24 and 36 feet, and you'd think, well, you'll use the 36 feet if there's 3 lanes, 2 lanes coming out, 1 lane going into the driveway. And the 24 feet of width for 1 lane in, 1 lane out, with the proper flare, the proper return, should work most of the time, and people understand that, and I think they always design that way. And there's good advantages, really, with keeping the drives relatively narrow. You're able to channelize the traffic a lot better. You're able to reduce the exposure pedestrians might have while they're crossing the sidewalk. That's all good. But, sometimes we run across some conditions that really just aren't typical. And frankly, I had to frame this particular example. I couldn't find any of these conditions. We've had the conditions that were discussed during design, but I don't know if we've really constructed any. But just wanted to make you aware of this. The typical site conditions that you see in a lot of our manuals and maybe presentations that you've seen, they're usually perfect. I mean, usually the site is a perfect square, perfect rectangle. It's plenty large enough for all the features that need to be within the property. And that's the way it is most of the time, but there's plenty times that folks try to fit businesses on properties that frankly just are too small, or it's an odd-shaped piece of property. And so that creates a lot of circulation issues, and then also creates issues maybe with the throat depth. You might not even have a throat depth hardly because of the way the property is designed. And so, for instance, in this particular example, and this is some things that had come up on, I know, on some design projects, you've got the fueling stations, very close to the right-of-way, and the aisle between the fueling station and the right-of-way, it's very narrow. And for a vehicle to come out, if they come out and pull up far enough, they're probably going to be out of the way if you have a 24-foot drive. But people aren't going to necessarily drive it that way all the time, and they might stop at such an angle and at such a location that they block the right turners trying to turn into the property, or could be left turners for that matter. And so you could have that traffic trying to enter the property slowing down considerably, or even having to stop. So in a condition like this, if it was me, you might need to try to widen the driveway some. Certainly you can't widen it too wide, but don't just stick with the standard, the 24 feet, because that seems to be the appropriate width of a driveway where you just have one lane coming in and one lane going out. Just really all I wanted to say about that. And this is kind of, these next few slides are a little bit drastic too, but actually these are things that have happened, and they involve, again, really construction projects or just, you know, design projects. And that's regarding one-way drives. Now, there's plenty of opportunities where one-way drives are used and used successfully. Usually it's going to mean that the internal circulation is such that there's absolutely no way you can go into the drive at one location and you can't come out but one location, and that's good when you're talking about one-way drives, because the thing that we certainly want to avoid is we don't want to have a one-way drive where folks are coming in when they should be going out, where there's a vehicle going out, or a vehicle's trying to go out and somebody's trying to come in the wrong driveway. So in this example that I've shown here, this is a rural area, and you just really can't control, or it certainly would be very hard to control one-way traffic in rural areas. Of course, in this particular example, first of all, the driveways are too wide. I suspect they're as wide as they are because of the delivery trucks trying to get to the site. There's no pavement markings or signs telling you they're supposed to be one-way drives. I mean, in this aerial view, you can pretty well see that they're supposed to be one-way drives. Another issue is that whenever you have a business that depends on passerby traffic, a lot of times by the time the motorist has seen the business and they want to pull in for the hamburger or they want to pull in to get gas, that they've passed the entrance driveway, they're going to make that turn into the business anyway, and so they turn in at the exit driveway. And as you can see in the other photograph, this is a situation where people have been turning into the exit driveway. In urban areas, we can also have a lot of problems if we try to install a one-way driveway in the wrong location. In this example, this is supposed to be a one-way driveway. Of course, I know it looks like a narrow two-lane driveway, but in this example, there's just very little distance between the edge of pavement and the edge of the right-of-way, and so you cannot geometrically design a driveway that looks like it's a one-way driveway. It's going to always look like a two-way driveway. So, and then obviously this driveway doesn't have any of the signs or pavement markings that should go along with a one-way driveway. The driveway next to it, to the right, excuse me, to the left, that's supposed to be a one-way driveway too, a one-way out. And obviously that would be impossible for people to really recognize it that way. And even if you have a situation where the drive is designed pretty well, and you've got your pavement markings that you need or should have in place, you know, you can still have problems. In this particular example, this drive is, like I said, it's designed and it's obvious that people are only supposed to go in this way. And then once you get in, if you try to come back out, you know, you see the do not enter signs, you see the pavement arrow pointing the wrong way, or the wrong way from where you want to go, and then we even have the pavement message, do not enter. But this driveway is awfully convenient. It's awfully inviting. It's right in front of the convenience store. It's right in front of the gas pumps. So you can see what happens. You know, you just can't control folks under certain conditions. So anyway, wanted to make you aware of these conditions that we've seen at one-way driveways. The concrete pork chop island, don't really need to say a whole lot about it. They're supposed to discourage left turns into driveways, left turns out of driveways. If you do not have a restricted median, if you don't do this, put in the concrete island, you can put in the painted island, and probably you'll even get less people paying attention to what you want them to do, to stay away from the left turns in and left turns out. But personally, I just don't like the concrete islands. Actually, this one's designed pretty well, really. The driveway is wider than many you'll see, so it's a little more easier for folks to enter and to exit the property, and maybe this wouldn't be as much of a hazard as some of the concrete islands I've seen, but there is still even damage on this particular one. But if it was me, I'd just bite the bullet and paint the island. I wouldn't put in the concrete island, you know, and I'm sure you have too. I've seen plenty of concrete channelization islands like this when we have raised medians where there's really no opportunity for somebody to make the left turn in or the left turn out. I guess what we're trying to do is to make sure that folks are aware that if they got to the median, there wouldn't be a median opening there, but I really just can't see that being a problem. And then the next feature, or features really I wanted to talk about, was the continuous right turn lane and the separate right turn lane. If I had my preference, I'd always use strictly just the separate right turn lanes. But we have conditions out there that, at least in my opinion, I feel like that maybe the continuous right turn lane is a better option than the separate right turn lanes. Regarding the continuous right turn lanes, I know some references discourage their use. The only thing I remember reading about the continuous right turn lanes is that you get situations or may encounter situations where motors get into the right turn lane, have their turn signal on, and the motor's coming out of the next driveway thinks they're turning into their driveway, so they pull out and they get hit with a right angle crash as they pull out. The vehicle with their signal on was actually intending to go up to the third driveway or a driveway further away. I guess that's always possible, and maybe it happens, but I'm just not aware of it happening, or really even happening a lot for that matter. But I am aware of some conditions that we've had with separate right turn lanes that really made life difficult. In fact, there's been several locations in northeast Florida I know where we've had enough problems that we had to eliminate those problems. So with the separate right turn lanes, you know, what we have encountered is that you'll get motors entering the first right turn lane thinking they're going to the second right turn lane. And then when that happens, they'll do one of a couple of things. First of all, as soon as they realize they're in the wrong right turn lane, they'll dart back out. And if they don't dart back out, it might be by the time they get in the right turn lane, maybe there's a large vehicle in front of them they can't really see. It's too late and they hit the curb, or they might hit the channelization island, or they might run over the delineators we put up so that motors will see the channelization island and not hit it. You have those occurrences, and then probably the worst conditions we have for this are where the second driveway, or up ahead at least, there's a traffic signal. So in those situations where we have a traffic signal, or sometimes a ramp like leading onto the interstate, you've got a lot more right turners in those conditions. So that's where we really seem to have these problems. And in rural areas, sometimes motors, because they're stopped at the traffic signal, and even though they might be 1,000 feet back, they might purposely get in your right turn lane to drive across that right turn lane to the next right turn lane to eventually get to the traffic signal. So as I mentioned, we've had several conditions like this some years back in Jacksonville, and we went ahead and connected to the separate right turn lanes. I mean, we couldn't correct it, so we went ahead and made the improvement we felt necessary to make it as safe as possible. So we added the continuous right turn lanes, and to my knowledge, we really never had any problem with continuous right turn lanes. There is something, or condition though, that really is a deal breaker. Pardon my sketch. Of course, I guess it's not quite as bad as the one on the narrow driveways. But one condition you just absolutely have to avoid is you cannot have a median opening in a continuous right and a continuous right turn lane together. In this particular little example, I'm showing a directional median opening, but it doesn't really matter if it's a directional or if it's a full median opening. If there's an opportunity for motors to make left turns where you've got a condition that traffic is backed up past that median opening, and most of the time that condition is probably going to be caused by a traffic signal. Sometimes, frankly, it happens all during the day, but it's primarily a peak hour situation, and the traffic stops on the red for the signal, and it backs up through the median opening, and people will be good Samaritans, and they'll allow a gap for that left turner to cross, and he can see that the folks are stopped, and he can get to the continuous right turn lane, but as we all know, that continuous right turn lane probably doesn't have the traffic queued back. Probably folks are maybe not free-flowing, but are able to make that right turn, and so you do have the free flow condition, unfortunately, right there at the intersection where they're trying to cross. And especially if the motorist has a passenger with him, then that can be a real serious right angle crash. So if you have that condition, or you will have that condition, you just really can't allow it. You've got to take some corrective action. It might be eliminating the continuous right turn lane. It might be eliminating the median opening. That would be a decision you need to make. Maybe try to ask yourself those same two questions. What's the safest option? What's the more efficient option? Now, the next item I wanted to talk about really was non-standard length turn lanes, either left turn lanes or right turn lanes. I know from time to time I hear folks say that they won't install anything or won't allow anything except the standard length turn lanes. And certainly that needs to be our first option, our first consideration. But plenty of times, for a variety of reasons, we cannot install the proper length turn lane. It might be within a median where you want to lengthen a left turn lane or install a left turn lane, and you just can't get the 185 feet maybe plus the queue that you might need for a 45-mile-per-hour speed limit. So you put in what you can. I mean, ideally you put in the entire left turn lane length as required using the proper queue and index 301. But if you can't do that, at least it's nice to try to get the queue length in. That way you get the through traffic, or at least the through traffic won't be running into the back of the last stopped vehicle. And even if you can't get the queue length in, especially for the right turn lanes, if it's smaller, we'll accept a smaller right turn lane in our district if the turn lane lengths don't meet the design standards. Now, the engineer of record, the engineer working for the applicant, he is going to have to come in, he is going to have to write the design variation. And as far as I know, every time one's been written, it's been approved by the district design engineer. And then the last feature I wanted to mention was the directional median openings. And again, to me, this, in many circumstances, this is a pretty good option. It, of course, has a lot fewer conflicts than the full median opening, and there's a lot of advantage to the public traveling up and down the roadway with the directional median opening. Now, I realize that every time we add another median opening, that's another location where we have conflict points. And so, our spacing standards are based on making sure that the through motorist is able to deal with the first conflict point, maybe we'll say median opening, and get past it, and then still have enough time to recognize the next conflict point and observe any issues or conflicts happening at that median opening, and be able to react and stop in time or react in time to avoid a crash at the second median opening. So I understand why we need to space our median openings out based on the road classification, and really primarily due to the speed limit. But I still think there's a lot of opportunities where the directional median openings have a lot of value. Now, we haven't really mentioned this procedure. In fact, there's just one procedure on median openings that the DOT has, and that procedure, you'll find it, well, no, that's in the planning side of business too. I'm pretty sure it's in the planning side of business. That's the median. That's the procedure that discusses when you should consider installing a median opening, when you shouldn't. It's also the procedure that mentions the Access Management Review Committee and sets the ground rules for the AMRC meetings. And what the procedure says today, it says that deviations for directional median openings do not need to be reviewed by the Access Management Review Committee. So I hope I'm interpreting this right, at least based on the old rule, the old procedure. But if you have a location and after you've studied that location and you determine that the directional median opening is the proper feature at that location as opposed to another type of feature or no feature, then you don't have to meet the 10% rule requirement where you shouldn't deviate full median openings by more than 10%. If you deviate by more than 10%, then that's okay as long as you've done the proper study to prove that's a good design. The old, I guess the previous procedure, same procedure, it went into a little more detail on directional median openings. It specifically said it's not subject to the 10% rule. The decision should be based on safety, geometric, and highway function, which certainly I'd agree with all that. And then the study, if it's going to require a study, which it should, then that study is going to be an engineering study. It should be written by a professional engineer, approved by a professional engineer. So I'd claim that this information that used to be in the old procedure just isn't needed anymore, but it still means the exact same thing in the new procedure. So the directional median openings, in my opinion, work most of the time. Two cautions here, though. One is that Good Samaritan crash that we just talked about, so you've got to be careful there. You can't create that condition. And then secondly, nowadays we've got some roads that they're pretty wide, and excuse me, got this dry cough. They're awfully wide, and you need to be careful you're not setting folks up where you put a median opening and place that left turn lane so that now they're crossing multiple lanes to get to that right, to get to the left turn lane. In that situation, maybe you shouldn't put in the directional median opening and require folks to travel further down the road and move over one lane at a time as they come out of the driveways and streets and eventually get to a median opening, left turn median opening, where they can safely make in this case, they'd have to make a U-turn and come back to wherever they were trying to get to. But that is a concern nowadays too, the distance that motorists need to cross. And that pretty well sums it up. Just about run out of breath. Be glad to try to answer any questions anyone has, and if you have any comments, I'd certainly appreciate the comments.
Right now, there are no questions in the chat. There is a comment, though, about driveways.
Okay.
That the state design office is currently working with the districts to revisit some of the driveway standards in Index 515. So that's just a point of note to the audience to know that they are considering revising them using smaller radius, for example, 10 to 15 feet. So just know that that they're taking things into consideration, like the pedestrians and the cyclists more, making it a little bit fair for all users.
Sure, and like you said, Anthony, we should be designing for all transportation users, which certainly includes more than the vehicles on the roadway. Yeah, thank you. I didn't know that.
You're getting a couple kudos in the chat. People saying great, good presentation.
Are they from people in my office?
No, Jim, this is Dennis. That was very good. Very good.
Thank you.
And again, everyone, at that TampaBayTrafficSafety.com is where the presentation, the PDF of the PowerPoint, as well as the actual recording of Jim giving the presentation, will be posted. We'll give folks a few more minutes here. Yeah, you had some really interesting notes there with the driving the Good Samaritan crash. That's something that we've done systemic evaluations for Peter and traffic ops to identify locations where you have that left turn lane through the continuous right turn lane to try to identify some of those spots and evaluate them to see which one should be closed. That's definitely one of the things that is, considering the safety of it. An interesting thing as well with access management that I find interesting that most people don't really realize, kind of a little factoid, that the greater the access management, the more directional medians you have and the better the right turn lanes are defined and everything, even though it reduces the conflict points, the better the access management, the greater the vehicular speeds are because there's less conflicts. And we see, although there's less of the angle type crashes, some of the crashes that typically are not injury, like your rear ends and your side swipes, end up having a higher injury frequency because of the higher vehicular speeds. So that's also something to consider that's interesting, that the nicer you make the road, the more people are likely to drive down it quickly because the function follows the form.
Yeah, that's a good point, Anthony, and I guess like I mentioned, just unfortunately, the more I guess you get to know about access management or really traffic engineering, traffic operations in general, it's, there's no perfect answer to just anything we do. There's always the other side, and it's just trying to perform that balancing act, and it gets pretty difficult. But certainly, the more information you have, like information that would be shared at the Safety Academy, it's certainly going to make us a better department, and for all transportation professionals, hopefully make them a little better in their profession.
Yeah, no, absolutely, and that's driving down fatalities through knowledge sharing was written on the bottom of every single one of your slides. I mean, that's kind of what we're doing, informing everyone and looking at it from the different perspectives helps identify those unintended consequences. You think, oh, at this location, let's go ahead and directionalize the median or do whatever, but then you have one of the slides that I think it's a great one also, the multi-lane, where you have the right turner from the driveway that tries to dart straight across to get into that first median opening. There's just unintended consequences everywhere. So having folks from the different offices do presentations and speak to each other, I think is very, very valuable. We all live in our own little world,
Oh yeah.
Anthony?
Yes.
When you are you still recording?
I am, yes, but
okay.
I can up the recording if you need me to. Yeah, I mean, there are no other questions in the chat. There's, some more kudos from folks. There was a couple of questions about the PDH credits and if contractors can use them for that. We're kind of addressing those in the background. But I can go ahead and stop the recording here. We'll stay on the line for a few minutes if anybody else has any other questions.